This is fluid coding and AI, and today GLM 5.2 gets a harder job than a launch recap. The question is simple. If GLM 5.1 was the "can it keep improving during long work" model, does GLM 5.2 actually make completed coding work less painful to steer? The previous GLM 5.1 episode was about long horizon work, planning, implementation, tests, failure diagnosis, and iteration. But there is an important caveat. The old workspace did not include local GLM 5.1 run logs, so this cannot honestly be a completed lab rematch. The fair regression is against the thesis. When the task gets long, does the model keep improving, or does it start making you babysit the loop? Z.ai describes GLM 5.2 as its latest flagship model for high-performance agentic tasks. The headline spec is a 1 million token context window, with the model card claiming long context support up to 1 million tokens. The agent story is more interesting. The materials talk about journey learning, state transition evaluation, and adaptive inference. In plain developer English, that means the model is supposed to learn from long tool use trajectories, judge intermediate states, and spend more effort when the task deserves it. The first-party benchmark table gives the hypothesis some weight. Z.ai reports GLM 5.2 at 62.1 on SWE Bench Pro, up from the listed GLM 5.1 score of 58.4. It also reports gains on NL2 repo, HLE with tools, and BrowseComp. Those are useful signals because they touch real issue solving, long repository construction, tool use, and browsing. But those are still headline scores. They do not tell us how many times the agent had to be corrected before it got there. Here is where my expectation changed. The official pricing page lists GLM 5.2 cheaper than the previously researched GLM 5.1 rates, 70 cents per million input tokens, 11 cents for cached input, and $2.80 per million output tokens. That sounds like an easy win, but completed work is not priced by one clean prompt. It is priced by retries, giant histories, repeated test runs, and the model's habit of writing a novel before touching the right file. Lower token rates can still lose if the loop gets bigger. A million token window changes what you can put in front of the model. It does not automatically prove the model uses the right evidence. For a real repo scale test, I would give the agent the full repository, relevant docs, failing logs, previous failed patches, and the test output that disproves its first idea. The score is not, did it ingest everything? The score is whether it finds the 5,000 tokens that matter when the next edit depends on them. The most useful regression test is the repair loop. Seed a small but realistic repo with one failing unit test, one failing integration test, and one performance regression. Give both agents the same budget and the same stop rules. After every red test, require the model to explain the observed failure before editing again. That one rule catches a lot of fake progress. If the agent keeps patching without understanding the failure, you are not watching engineering. You are watching autocomplete with a keyboard. For GLM 5.2, the metrics I care about are boring on purpose. Time and cost to first screen test. Time and cost to final accepted result, number of repair loops, repeated commands, context drift events, human steering count, final diff size, unrelated churn. And one more, test repair quality. Did the model fix product code, weaken the test, delete coverage, or quietly move the goalposts? Because nothing says senior engineer like making the test less correct until it passes. There is another reason to be careful with the public numbers. The harness matters. Z.ai's materials mention different terminal, bench versions, and harness labels, including terminal. Bench 2.1 with Terminus 2 and a best self-reported quad code harness result. That does not make the numbers useless. It means the agent scaffold is part of the product. A harness that forces receipts, smaller plans, and test gates can make the same model look much more disciplined. GLM 5.2 also does not need a fake victory lap. In Z.ai's own comparison table, Claude Opus 4.8 leads GLM 5.2 on several long horizon coding rows. Anthropic also claims 1 million token context and stronger long coding behavior for Opus. There is one external semgrep write-up where GLM 5.2 looks strong in a specific cyber benchmark setup. Useful signal, yes. General coding agent verdict, no. So my verdict is, test GLM 5.2 if your coding agent pain is long runs, noisy context, and too many human nudges. Do not test it because a bigger window sounds magical. The useful upgrade is lower steering cost, fewer repeated mistakes, better recovery after a failed test, less unrelated churn, a cheaper path to the same accepted result. If it wins there, the million token context matters. If it only makes larger prompts and longer transcripts, then it is just a nicer junk drawer with an API bill. If you want more practical coding agent tests like this, like the video and subscribe to Fluid Coding and AI. The next time a model claims better long horizon work, we will ask the same annoying question: did it actually finish with less babysitting?